Hello, my name is Carla Baresi, and I'm going to discuss the Stuxnet worm and flame malware. So the background. Stuxnet is known as the world's first digital weapon, which reported to be the first worm possessing the capabilities and functionalities to launch attacks against essential infrastructure. Essential infrastructure included nuclear equipment found in nuclear facilities in Nansak, Iran. In June 2010, Nansak nuclear facility was placed under high scrutiny by IAEA inspectors who reviewed footage from surveillance cameras installed at the facility. The reason why surveillance cameras were installed at the facility was that it was noticed that Iran technicians at the plant were replacing an exceptional number of centrifuges at the plant used to enrich uranium at frequent rates. Frequent replacements of the centrifuges were due to the fact that centrifuges were failing at high unexpected rates. The average lifetime for a centrifuge was reported to be a few years, so this disturbance led IAEA inspectors to conduct an investigation. Kaspersky and Symptomatic Labs intervened to assist in the investigation, in which it was confirmed that the presence of malware called Win32.Stuxnet infected the laptop of an engineer who was employed at the Nansag nuclear facility, was responsible for the constant and repeated failures of centrifuges. The Stuxnet worm design and functionality. Stuxnet worm was designed to portray four main characteristics, which are self-propagation, command and control, stolen verified driver certificate, and a rootkit. The main functionality of Stuxnet was to reprogram the programmable logical controller, known as PLC, to cause physical harm to hardware equipment in nuclear facilities. It was able to cause harm to hardware equipment in nuclear facilities while hiding its identity through malicious activities. Stuxnet was able to carry out malware attacks by operating at three levels. The three levels included compromising Windows operating systems, compromising Step 7 Siemens SCADA software applications, and the programmable logic controller PLC. Stuxnet was successful in compromising the Windows operating system of the PLC by incorporating self-propagation techniques in which Stuxnet was able to distribute itself as a set of 4 zero-day exploits. Usage of 4-day exploits were difficult to locate and highly sophisticated. The main technique used by Stuxnet to distribute itself in the exploit was delivered through a USB drive, in which Windows became vulnerable to incorrect parsing of .lnk files. LNK files were a core component of Microsoft Windows to enable the malicious code to be executed through the LNK file. Stuxnet was able to replicate itself in the Windows operating system by utilizing a print spooler service delivered through the exploit MS-10-061. MS-10-061 targeted Windows machines in which the file and print sharing options were turned on. Flaws presented in the print spooler allowed documents to be printed to files in Windows system directory, launching the execution of two files. Stuxnet utilized root capabilities to compromise the Windows system by being able to hide files and inject code into processes in which kernel mode drivers were installed and signed by legitimate certificates. The certificates were stolen from the companies Realtek and J Micron. Successful installation of the rootkit drivers were prompted by the signing of drivers, which allows Stuxnet to remain undetected for a long period of time. Command and control server communication on the Windows system was interrupted and compromised by Stuxnet, in which the command and control server set updates and codes to be executed for the Stuxnet client. Simultaneously, the Stuxnet client was able to steal critical and proprietary information on the SCADA industrial control systems. Stuxnet compromised Step 7 SCADA software application by locating and utilizing APIs to open up Step 7 projects. Upon opening the project, the path of the folder was revealed, and the folder became infected, leading to the execution of Stuxnet. Stuxnet began to intercept communications between Step 7 software and PLC, which led to aluminum centrifuge tubes expanding in parts. PLC rootkits were implemented to maintain the infected code blocks on the PLC from being detected, in which attempts made by Step 7 software application to access an infected block in the PLC intercepted the request and modified to prevent Stuxnet from being revealed. Applications used to compromise the target and remediation actions against Stuxnet included the worm being discovered by Sergey Olsen, a security specialist at Virus Block Ada in Belarus. Sergey carried out an investigation assisted by fellow security specialists at Virus Block Ada, in which they determined that the virus infected the client's computer was connected to a zero-day exploit. It seemed as though the zero-day exploit was also linked to the Stuxnet attack, which was associated with the same design and functionality of Stuxnet. Microsoft responded by releasing a patch MS-10-46 in August 2010 in response to Stuxnet. However, it was later determined that the Microsoft patch possessed security holes in which the patch was capable of being re-engineered, making the system continuously vulnerable to Stuxnet. 2014, Microsoft released an updated security patch to combat Stuxnet, which was called MS-15-020. Also, Siemens responded to the Stuxnet invasion by launching a detection and removal kit for Stuxnet. The Flameware malware. So Flameware malware is a highly sophisticated malware known as W32.Flame Skywiper, which was intended to steal different databases thought to be in association with Stuxnet. Characteristics of Flame include containing 20 different plugins and modules accounting for Flame's substantial size of 30 MB. Multiple levels of encryption, rootkits, and some of the code resembles LUA, a programming language which was primarily used for game development. The main functionality of Flame was to steal data through using three primary modules: Jimmy, Microbe, and Flask. Jimmy is a file scanner which scans the storage media of the infected system for files. Microbe functions to record audio conversations by secretly turning on the computer's microphone to retrieve information. Flask operates to steal and collect a vast amount of data and possesses the ability to open TC and UD connections along with web browser cookies. A unique functionality of Flame is that it's Windows' first malware to utilize Bluetooth to gather information on an individual's physical location, social networks, address books, and text messages. Applications utilized to compromise the target and remediation actions for Flame. So Flame was identified in May 2012 by Kaspersky and Mahir Center of Iranian National CERT. Kaspersky Lab was successful in identifying Flame by file names in MD5 hashes, which were specific to viruses and compromised computing systems in Iran's oil industry, government organizations, and private and public institutions. CERT responded to Flame by releasing a detection and removal tool for Flame. After Kaspersky discovered Flame, command and control servers utilized the module Suicide to serve as a command for Flame to delete itself.